Hello students, in this video I am going to explain SN1 and SN2 reaction. Before going through this topic, I want to teach you some basics related to it. Now let's start. Reactants reacts and form products. But reactants is of two types, substrate and reagent. Substrate is the substance which is being attacked by reagent, and reagent go and attack the substrate. Reagent is of two types, electrophile and nucleophile. Here we discuss about nucleophile. Nucleophile may be of two types. First, negatively charged species like OH negative, CN negative, etc. and neutral species NH3, H2O, RNH2, etc. But these species having at least one lone electron pair. Another factor which affects the SN1 and SN2 reaction is solvent. Solvent is of two types, polar solvent and non-polar solvent. Polar solvents which have electronegativity difference between the atoms, and non-polar solvents which have no electronegativity difference between the atoms. Polar solvent is of two types, protic or protic. Protic means which release H ions like H2O, C2H5OH, CH3COOH, etc. Aprotic which do not release H ions like CH3, C double bond O, CH3, or CH3S double bond O, CH3, dimethyl sulfoxide, etc. Non-polar solvents are may hexane, or cyclohexane. These two factors, type of reagent and type of solvent which we used in the reaction, it decide the SN1 reaction takes place or SN2 reaction takes place. First we see SN1 reaction. SN1. SN1, S means substitution, N means nucleophilic, and 1 is the order of reaction, which is experimentally proved. We can say this reaction unimolecular substitution reaction. When protic solvent is used, then if substrate is alkyl halide, and nucleophile is from KOH, then C product will be tertiary alcohols. But before going through these steps, first this reaction completes in two steps. In first step, carbocation forms. Because CCl bond have polarity and it is a weak bond, Cl takes 2 electrons and forms Cl negative. And this carbocation attracts nucleophile. This nucleophile may attack from the front side or either from the front side or from the back side. When it attacks from the front side, the product form and the second one is this. It can rotate the plane polarized light towards right side and it rotates the plane polarized light towards left side. This is dextrorotatory and this is levorotatory, and the product forms the racemic mixture. When SN1 reaction takes place, we obtain racemic mixture. Pair of enantiomers are obtained. 50% dextrorotatory and 50% levorotatory. But in SN1 reaction, tertiary halides are more reactive than secondary halide and 1 degree halide, and protic solvent, polar protic solvent, and we can say PP solvent prefers SN1 reaction. So is that clear? Next we'll see SN2 reactions. And now SN2 reaction. Bimolecular substitution reaction. If substrate is halide, alkyl halide plus KOH, due to weak bond between CCl, it gets partial positive charge and it gets partial negative charge. It gets partial positive charge, so nucleophile attacks on this carbon, but from the opposite side of the halogen atom, because due to avoid repulsive force of Cl, because nucleophile is electronegative and Cl is also electronegative and it repulses the OH, so OH attacks from the opposite side of the halogen atom and it forms when it accommodates OH nucleophile, the bond between CCl comes under strain and it forms a transition state. This is transition state. Here the carbon is tetrahedral and sp3 hybridization, and here trigonal planar and hybridization is sp2. It is unstable, so finally it forms final product and it will be alcohol, and this is also tetrahedral and sp3 hybridization. Primary alkyl halide favors SN2 reaction, then 2 degree, then 3 degree, because when nucleophile attacks on this carbon, if there is alkyl groups, if there is bulky groups are present or alkyl groups are present, it is difficult to attack of OH on that carbon. So primary alkyl halides favors the SN2 reaction and tertiary alkyl halides favors the SN1 reaction. And polar aprotic solvent favors the SN2 reaction. Here, due to presence of Cl, the shape of tetrahedral carbon is this, and here due to OH it moves to the opposite side of the carbon. So this is called molecule change its space and the point of molecule is change its place, and this is called inversion. And this process is known as inversion. So SN2 reaction show inversion and SN1 reaction forms racemic mixture.